Welcome everyone to Science in Action. Today is October 27th, 2020. Welcome to everyone in the chat. If you guys are seeing this on YouTube, thank you for being with us. We hold Science in Action every Tuesday, 4:30 to 5:30. Today, we are so very excited to have one of our instructors from Skyline College, San Francisco State, and La Cunada College, Malori Redman. Thank you so much for being here, sharing your educational journey and your research experience.
Thank you so much for having me. Okay, I think the time has come, I suppose, to share my screen, yes? All right, share screen, desktop 2. All righty, so yeah, essentially, I kind of just wanted to share with you all kind of my journey, right? So we all have various educational journeys. Maybe some of us are returning back to school. Maybe you're, I know I have several middle college students. And so I just kind of wanted to share my personal journey. So thank you, Brian. As you said, I teach at Skyline and at La Cunada. There I teach oceanography. And at San Francisco State, I teach meteorology, and the class is called Our Dynamic Weather. So they're all kind of, intro level oceanography and meteorology classes. And I quite love it. So yeah, I would not be here today if it wasn't for these 3 lovely gentlemen. So Andrew Oliphant was my PI during undergrad and my advisor during undergrad, one of, I should say. And then Lon Hood and Tom Galarney were my advisors in grad school. So I just wanted to share that. Also, if anyone has any questions for me, I'll kind of be monitoring the chat. So if you want to ask something, I'm happy to have a look at the question and answer it in real time, or you can save questions for later. I'm very open to any and all of the things. So there's that. Okay, so just kind of a general overview of what I wanted to talk about today. Kind of highlight my educational journey and the struggles that I endured alongside of it. So I'll start with the schools I attended and why I chose meteorology, because who chooses earth science these days? Somehow I did. And then I want to go into some of the research projects that I've done in my time at school as well. So my first in the field research project, which was in my undergrad, we went to Burning Man. I got paid to go to Burning Man. How fun is that? So that was cool. And then in between grad school or undergrad and grad school, I had to take some time off. So I just want to share some of my journeys with you, some pictures and such. If you're a student of mine, you know that I try to advocate for traveling as much as humanly possible. So you get to, hopefully I can inspire some of that into the rest of you all. And then I want to dive into some of the grad school research that I did. And I'm going to warn you right now, I'm going to kill you with panels because we're working through a bunch of phases of stuff. So it's going to be very panel-y, but I'll try to step you through it as much as I can. And if you don't understand anything that that research comes through, that's totally okay. I'm going to do my best, but yeah, these are the MJO and the QBO interactions. It's a lot of things going on in there. And then if I have time, if I speak fast enough, I want to kind of talk about a dream case study that kind of comes around. It kind of brings all of my grad school research all together and all of that. So where did I begin? I started undergrad at San Francisco State University in 2009. And initially my major was psychology. I came from a broken home. I've always wanted to help people. I was in therapy for a good portion of my life. And so I wanted to be able to help other people as well, right? And so so I wanted to do that. But if anyone here is familiar with what happened during that time, we were in a recession, right? So there were huge budget cuts to education, which meant furlough days, reduced classes, even to try to get into a general psychology class at SF State. even as a freshman, and you have to take general psych to take any of your other psych classes, was nearly impossible for me. So, and unfortunately, that might be something that occurs in the coming years because COVID. So we're likely going to see some more budget cuts, unfortunately. So what I had to do in order to keep a good class load and to, you know, I wanted to finish relatively on time, right? So I had to take classes at Diablo Valley College. So as I should back up a little bit, I went to high school in Danville, if you're familiar with the East Bay area. So I moved, I should really back up even further. So I grew up in Iowa and I moved to California when I was 15. So I was a sophomore in high school. I went from a town of less than 1,200 people to a school of more than 2,000 students. Talk about a freaking culture shock. That was nuts. But because I lived over there for a time, I was able to, I went to DVC, or part of my time was at DVC. But you know what? I also was so annoyed with the fact that I had to pay full-time fees at SF State, even though it was only 9 units, but still also pay for DVC. So I know the financial struggle for sure. Oh, and I guess I should point out that I ended up paying for school on my own. My dad paid for a couple of years and then we had a pretty big falling out. And so he cut me off. And so I had to pay for everything myself. So I had a lot of jobs. I was working for everything. I didn't qualify for financial aid because both of my parents made too much and I couldn't prove that I was completely dissociated from them. So if you're a working college student, y'all, I feel you on such a deep level for sure. So why did I go from psych to meteorology? That is a huge shift, right? Like how did that even happen? Well, as I said before, I grew up in Iowa, and there's actually fun weather in Iowa. They get tornadoes, they get hail, they get all these huge thunderstorms. But additionally, my dad and 4 of my brothers are pilots. And if you're a pilot, obviously you're flying a thing in the air, so you have to know what's happening in the air, right? So meteorology and aviation go very, very much hand in hand. So I'd always kind of had that in my brain. And my first semester of college at SF State, I took an intro to meteorology class. Because you know when you're going through and you're picking your science classes, it's kind of like electives, right? As long as it's a physical science or a life science or, you know, that kind of thing. So I was like, hey, meteorology, I like that. That was really fun when I was in Iowa. Let me take that. It's always something I would actually enjoy taking. So I took that with my later, one of my other advisors, Dave Dempsey, and his classes were so freaking hard. I got a B+, I think, and he was like, you did the best in the class. And we went to, the department chair sent me an actual formal letter asking me to join the department. But I was like, no, I want to listen to people's problems for the rest of my life. I don't want to look at the weather. That's ridiculous. But again, with that, with all those budget cuts and finally getting in to see an advisor from the psych department, she was like, it's going to take 7 years to get your 4-year degree. And I was like, what? And then I was working at Starbucks at the time, and I was talking to some of my regulars who were psychologists, and they were like, yeah, you're going to have to do unpaid internships for 1 to 2 years. You're going to have to go to grad school. You're going to have to get a master's degree. You're going to have to get a PhD. And I was just like, oh no, I can't do this. Absolutely freaking not. So I went and spoke to my professor from my intro to meteorology class, and we kind of talked it out, and I reconsidered. And so I joined the department and I joined the meteorology program, but I had to catch up on all of my math and physics courses. So meteorology is extremely math-based and extremely physics-based. So I had to take Calc 1 through 3, and of course, before you take Calc, you have to take pre-Calc. So Calc 1 through 3, differential equations, linear algebra, statistics. I had to take again. I took it my first semester just to get that out of the way because I hate stats. But I took elementary statistics. Turns out I had to take probability in statistics, which is just like one number above, but it had to be that higher level. So I had to take the same class again, which was really frustrating. I hated it so much still. And then, you know, I really enjoyed my physics classes. It's physics with calc, which I think is probably much easier to understand. But so I made friends with all my calc and physics courses. It's basically all the same courses that engineers take, right? Because you have to have that calc and physics base in order to do whatever sort of engineering you're going into. So I made a lot of friends within different departments. I was also one of the few females in my physics classes, by the way. It's not a very high female spot. So within that switch and kind of getting through my education and getting through all those classes, I also had 2 internships. So one of which was with the National Weather Service. So we got to go see a weather balloon launch, this is me and my colleague and friend, Emily. And then this was actually kind of in the Federal Aviation Administration home base, which is in Fremont. And so this was my mentor, Ashley. And so, of course, you got to take pictures so you can share on social media, right? If it didn't happen, if there's no pictures and it didn't happen. I had to go through the depths to find this picture. But anyway, so these were kind of the products that they used. So it was a really, really good program. I really enjoyed it. And then my second internship was with the Climate Change Scholars Program at SF State. So what they do, these are all folks from various disciplines. So my buddy Ryan and myself were the atmospheric scientists. We have some geologists, biology, chemistry, social sciences, like everything was all intermixed in here. And we were doing various kinds of climate change research. And if we did that, then they paid for a semester of school. And I was like, bruh, I'm paying for school all on my own. I need all the help I can get. You know what I mean? So I did 2 semesters of this, which was a really fun and great experience. So yeah, so after 2 internships and at one point 3 jobs, 1.5 hours commute each way later, I finally graduated. I did it. It was amazing. Best day. Such a really fun day. And this also just goes to show this was our whole department that graduated. So the Department of Earth and Climate Sciences at State is super small, so we're very tight-knit. The advising is extremely personal. So just to put in a little plug here, if anyone wants to get a degree from Department of Earth and Climate Sciences, we're nice and small. And these were the meteorology folks. And I also just want to say a little heartfelt thank you to this gentleman here. This is Dave Dempsey. He was my main advisor pretty much through everything. The hardest professor I ever had. He was so tedious. Like, he would knock off 1/8 of points for stuff, you know what I mean? And I barely passed his classes, but I appreciated all the steps he taught me along the way. He was so dedicated. At one point when I was living in Danville and commuting, he stayed on the phone with me for 6 hours to make sure my computer program would work. Like, he was just the most dedicated professor ever. And unfortunately, fortunately he retired a couple years ago, but unfortunately over the summer he was involved in a bike accident in Chico, and he unfortunately passed from that. So hang on and thank your advisors every step of the way. You never know when they're not going to be there. He also very much helped me in my teaching process too, because, you know, he taught the same class that I was teaching, and so he shared his resources and all that stuff. So thank your advisors at any moment you can. Okay, so I finally graduated, right? Oh, thank goodness. Finally got that out of the way. So I was so burnt out, y'all. I know the burnout. It is so, so real. So I was like, you know what? I gotta go. I gotta get out of here. And one of my girlfriends and I, we went to Zeitgeist, which is a beer garden in San Francisco, shared a pitcher of beer, and bought one-way tickets to Australia. And And the next day we were like, did we really do that? Yes, we did. Okay, tight. I guess we're leaving now. And so we went to Australia and New Zealand, and we lived in a camper van for 3 months. So we started in Melbourne, and then we went up to the Uluru, which is the center of Australia, and then over to the east coast, basically where the Great Barrier Reef is, and then drove again all the way down and pretty much made a big old circle, which was so much fun. It was so awesome. It was so expensive, but it was really, really cool. And then in New Zealand, we went down to, we flew into Auckland, which is in the North Island, and then we drove immediately down to the South Island, took a ferry over, and so I don't know if anyone else here is a Lord of the Rings fan, but your girl is, and they filmed a lot of Lord of the Rings on site. And going there, you see why Peter Jackson was like, yes, we are filming here in person. Yes, please. But then after 3 months, my best friend, she got a working visa for Australia. And I was like, I want to go to Southeast Asia super bad. So I flew up to Thailand. And so I spent time in Bangkok, and then I went down to the islands of Koh Tao, Koh Samui, and Koh Phangan. And then after, also I did a 10-day silent retreat there, which that's exactly what it sounds like. 10 days meditating, no voices. It was intense. Very, very intense, especially when you're in a jungle and like there's all these creatures and spiders that are literally this big just hanging out right above your toilet. Yeah, super fun. But so that was amazing. And then I went down to Malaysia, the island of Penang, which is pretty much, it's really close to the border of Thailand. But I spent 3 weeks there at a cat sanctuary volunteering to help raise cats for about 3 weeks, which was really cool, but also really depressing at times. It's basically an expatriate, or what we call an expat American. She had this little shack on a beach. I slept in a hammock for 3 weeks on the beach, which was amazing. But she kind of was in like denial a little bit. If anyone has seen the show Hoarders and like how they keep a bunch of animals sometimes, she was kind of in that same boat. So there was a lot of loss, but I also made a lot of friends, and we got to hang out. Lifelong friends. Is very, very cool. And then my partner came and joined me, and we went down to Singapore, Indonesia, Vietnam, and Cambodia. And so we did that all within a month, which was a lot to do when I had been like kind of stationary in these various places. So then after all of that, I ran out of money. So I had to come back home, unfortunately. But then I worked some more, saved up more money. And then my partner and I went back to Southeast Asia for about 2.5 months, where we went to northern Thailand, Myanmar, which is like stepping in a time capsule. And then we went down to Bali as well. So just to kind of iterate how much I love traveling, the 2.5 months, people are like, that's probably so expensive. Now, including airfare and living kind of lavishly, like staying in hotels, having spa days and things like that, only about $3,000 for 2.5 months. So, and including airfare. So by the way, round trip from SF to Bangkok is only like $500. Just throwing that out there. But in between my first travel and my second travel, I applied to grad school, which, I mean, I'm sure as many of you know, applying to schools is such a pain in the booty. Like every school has a different layout and whatever. So I applied to 5 different schools, and I will share which ones I was accepted to in just a few. But first, I want to share some pictures from my travels. So this top left is from Australia. This was our first camping night, which was really cool, kind of just south of Melbourne. This was in New Zealand, which again, just absolutely amazingly picturesque. This little river here is a glacial runoff river, which we camped next to for 3 nights, I believe. Super, super cold, by the way, but really, really clear, even though this water is moving super fast also. This was moving a super massive ton of water. So we actually had to, like, in order to kind of bathe ourselves, we wrapped a rope around us so we wouldn't like float away. But very chilly. Woke you up in the morning, that's for sure. This is the Milford Sound up here in the top left. It took my breath away. Just absolutely insanely picturesque. It's where they filmed part of Lord of the Rings. I went bungee jumping for the first time, which was a crazy, amazing experience. This was my first night on the island of Koh Tao, or first morning, excuse me. This was sunrise. So when you're traveling to the islands, you take an overnight train and then a ferry, and this just takes so much, but just absolutely gorgeous once the sun finally comes up. It's very, very rainy there. And if you want to see the most Buddhas you've ever seen in your entire life, go to Southeast Asia. So many Buddhas everywhere. And even though I grew up in Iowa, Myanmar was the very first place I ever saw a tornado. So that was crazy. So many temples and pagodas and stupas, all of these things just all over the place. This is in Bagan. If you're not familiar with what Bagan is, or frankly, even Angkor Wat, back in like I believe the 11th to 13th centuries, these kings were pretty much having all pissing matches with each other, be like, I can build the most stupas. No, I can build the most stupas. No, I can build the most temples. So it's resulted in these very beautiful places that have gigantic temples and things. So Angkor Wat is down here in the bottom right, and Bagan up here. And when you're in Bagan, you're literally just cruising around on little motorbikes. That's my partner here. But I thought the sunset here was really cool. And notice how the sun is red? It's because the pollution there is so terrible. Remember when we had really bad pollution here from all the fires, and the sun was like that apocalyptic red? Same thing, but smoke from fires in Indonesia, actually. This was a view from our porch in Bali, which was absolutely amazing, which was $10 a night, by the way. We went and saw the elephants in Thailand. I also have to put this plug out there. If you're gonna ever go to Thailand and go to an elephant sanctuary, do your research. If you can ride the elephant, they're abusing the elephant. So do not go to a place where you can ride an elephant. And then this was just a shot from when we were flying into Myanmar, I think, just to kind of show again the pollution, that layer of nasty, nasty pollution, a combination of actual pollution and fires. So Indonesia has a slash and burn season, / they're also making room for palm oil fields, which is terrible. So, so they burn everything and burn all the Indonesian rainforest, not all of it, but they burn the Indonesian rainforest. Anyways, so those are some of my journeys. I wish I could really just share all of my pictures with you when I was going through and making this. I was like, oh, now I want to go back. But so I came back. Or before I went, I was accepted to some schools. The first school I was accepted to was the University of Alabama in Huntsville. If you're a student of mine, I bet you understand that I probably would not have fit in Alabama very well, but that's okay. This school would have been the best for storm chasing. So I kind of had two routes that I wanted to go for grad school. It was either severe storms and like chasing tornadoes, or tropical cyclones. So those were kind of my two concentrations. And I visited there before I left for my second Southeast Asia trip, and there was no guaranteed funding. So that was kind of like, And then I also got accepted to University of Arizona. Again, best for tropical meteorology. I didn't get to visit there before I went, but guaranteed teacher assistantship and full funding for the first year. So I essentially took that. But you know how I found out that I got into University of Arizona? I was checking my junk email, and my acceptance letter was in my junk email. So always check your junk email, folks. Always. Even if you hate it and you get all those weird Viagra ones, you're like, well, I'm not even a dude. What the heck? But so moral of that story, especially if you're waiting for acceptance letters, always check your junk email. Okay. So I went to grad school, University of Arizona in Tucson. After 2 years of lots of tears, lots of beers, lots of frustration and aggravation, but also a bit of fun too, I graduated again, yay! And then I had my master's hood. They hood you, your advisor hoods you. It's really kind of cool. I loved it. These are my parents, by the way. And even though grad school was super, super hard, I really loved it. I was more mature, and I was able to handle the pressure of it better than I was in undergrad. I had the passion behind me, right? If you don't have the passion, it's so hard to actually get into what you're studying, right? And I tell this to my students too, for projects that we're doing, like do something that you like, that you enjoy. Otherwise, you're not going to want to finish the project, right? And I also had an amazing mentor and advisor who let me cry in his office for hours, cumulatively though, not just spending 5 hours crying in his office. It was probably really like 10 hours over the course of the 2 years. And I actually felt like I finally understood the material. So that was a really fun thing for me, at least. You know, so if you're thinking about grad school, you're like, oh, I don't know if I'm gonna like it or if I'll understand everything. Let me tell you that you probably will. If it's something that is in your future, I would highly, highly recommend it. So Tucson was over me. I was over Tucson. It gets to be 120 degrees there in the summer. And I did make a lot of friends there too. It was nice. I still worked, right? Because my funding only went so far and I like to have fun and spend money. So I got to make money to spend money, right? But so after I graduated, I moved back to the Bay Area. And 3 days before my official move, I had a phone interview with the department chair from my old department at SF State. And within a couple of days, she gave me the position. So I have the pleasure of now teaching an intro to meteorology course. But that started 3 weeks after my interview. And I was also going to Burning Man this year too, as well. So it's like, oh man, I really had like 2 weeks to prepare and then a week at Burning Man and then come back and then start teaching immediately. Like, it was nuts. And then the next year, I got an email about Skyline needing an oceanography instructor. And I officially got that position 4 days before the start of the semester. So I had 4 days to prepare for a class that I took a couple of oceanography classes in college. So my undergrad degree is technically in Atmo and ocean science with an emphasis in meteorology. So I did have a bit of an ocean background. It's not like I have my master's in oceanography, but I knew enough to be able to teach it. And then thankfully I work really well under pressure. So I was able to kind of get things going. And I will say my first semester of oceanography, I was definitely like taking a week at a time. I was only a week ahead. So yeah, that's kind of my entire journey of my education and kind of where I'm at now. So now I live in Oakland, moving to San Francisco next week. And I'm teaching, at SF State, Skyline, and La Cañada. And I think I'm also taking up another oceanography lecture at CSM. So if anyone is not in my class and wants to take my class next semester, shameless plug. Okay, so that's my journey. But what the heck did I research getting all of those degrees? What did I do? Well, as I alluded to before, and also outright said, in undergrad, I had the opportunity to go to Burning Man and do a research project at Burning Man, which was just an absolutely wonderful and crazy, amazing experience. So whoever says that science isn't fun is a liar. So this was one of the towers that, the big tower that we erected within the city. So this was in process of flipping it up basically. So we brought it out on this huge trailer and you pretty much hook up all the instruments and then you flip it up and then it kind of unfolds, or not unfolds, but kind of goes all the way up. It's about 100 feet tall-ish. And you can kind of see some of the instrumentation on here as well. So we were measuring temperature, humidity, water flux, carbon flux, wind speed and direction with this weird little like anemometer thing that looks like an alien. And then we set up a smaller tower outside of the city as well. So we were able to do similar sort of observations, but outside of the city. And I also rigged up this little bike here to be about 2.5 meters tall. So just like 6.5 or almost 7 feet, I think. And you can kind of see along the side here, they're what we call thermocouples. So that was measuring temperature and relative humidity all the way up from about, I think, 6 centimeters above the surface all the way up to 2.5 meters. And my buddy Ryan was kind of my guide. So we would ride the bike through the city and he would make time marks on when we crossed a various street. Because when you're doing transects like this, you have to You have a GPS, so you're able to track where you're going, and also just to have a second buddy there to also just verify exactly where you're at. So what I looked at specifically was called the urban heat island effect. And if you're not familiar with what that is, that's totally fine. It's essentially this idea that a city is warmer than its surrounding rural environments. And this is actually a really big thing in Phoenix. It's a very visible thing in Phoenix, where Phoenix itself is a huge city, but it's in a desert, right? So at night when the sun goes down, the city is still radiating off all of this heat. And it can be almost anywhere from 10 to 12 degrees difference between the outer deserts. Kind of crazy. So if you're not familiar with where Black Rock Desert is, it's in Nevada. So here's California, we right here. Nevada's over here. So this box here is kind of blown up right here. It's kind of to see it within where the counties are. And if you're not familiar with the city itself, so how they set it up, it's like a clock. So this is 10 o'clock, this is 2 o'clock, 6 o'clock, we got center camp right here. And then as you go out of the city, the streets are alphabetical. So here's where the man is at the center of everything. And this was where our main Flux tower was. This is where we were camped at. And then we put another station outside of the city, right? And we were able to get placed here specifically because overall, this is called a wind rose. So overall winds are coming off of the city, right? So it's that southwesterly winds. So we wanted to get all of this data from what's coming off of the city that was there. So there were various projects that were in like this main thing. And one of them was to look at carbon flux. Another was to look at surface roughness. So how buildings and structures, how they modify wind patterns and little eddies. And then, so here's some more pictures here. So we put a GoPro up at the top of the tower. So we were able to get a nice little time lapse of when we got there before the city, or as the city was being built, as the city was going, or as the festival was going on. This is our little itty bitty tower. And by itty bitty, I mean still about 7 feet tall, but not as many instruments. And this was our tower erected up from when we first got it up to when it was around the city. You'll also see here maybe that sun is kind of smoked out a little bit. That's because this was there were huge fires in 2013 as well. So there was a lot of smoke in the air, which was crazy. And then just another picture of me riding around with my bike. These images, by the way, are in a published article that I can link if anyone wants to read it. So if you're familiar with Burning Man, you got to do a lot of art and a lot of interactive things. So we had to create these projects that were interactive and that you had part of your camp. So on our tower, on the guy wires, we had all these lights, and the lights flickered and changed with the winds. So when the wind came in at a certain speed or direction, then there was a different light thing. I didn't man that part, so I don't know all the details to that one. But we also projected our real-time data onto one of the domes that we had set up there as well. So you could come in, you can go into a dome, we'll make you a drink, and then you can just sit back and look at this real-time data of one of the one of the sensors. So that was pretty cool. And our camp name was Camp Antenna. So it was a really cool, it was a really fun project. And my advisor from this, Andrew Oliphant, he wants to do it again, but right now he's a department chair, so he's like, I have no time. But he does want to do a follow-up, and he's invited me to do it if we can get some funding, which again, by the way, this is funded by the National Science Foundation. Bam! So crazy. It still blows my mind, however many years later. So with my research, was there an urban heat island? No. There was actually an opposite, where the city was, very, very small, but it was a couple of degrees, or about a degree or half a degree cooler than the outer desert. We have a couple of ideas of why that could be, but we would have to go back and do subsequent research in order to kind of really figure it out. So this is looking at urban heat island. That's what that stands for, Jocelyn. So the red dots here say positive heat island. The blue is negative heat island. So essentially within this system, there's more blue than red. So, so we would say that there's a negative heat island. So one of our theories as to why the heat was slightly less inside the city, so something that you have to do with your gray water or your wastewater, you have to be completely self-sufficient, right? So you can't, and the playa is a sacred space. It's controlled by the Bureau of Land Management. So you have to keep things pristine. So you can't just dump your water everywhere. The only water you can dump is the melted ice from your coolers. So our theory is that all these camps have to set up these really interesting and intricate and fascinating evaporation pools, basically, to help evaporate the gray water away, because it's a pack it in, pack it out situation. So if you can't get rid of your gray water, you're kind of screwed. You have to take it home. So our theory is that there was just more moisture in the air, which maybe caused it to be a bit cooler. Again, we would have to go back and do some more research on that. And this is just kind of looking at the bike transect. So the various heights, we can see quite clearly how there is a temperature inversion at night. So the blue, my 15 centimeters is cooler. If we're looking at temperature, cooler than my 250 centimeters. That makes sense at night. Yeah, so I would try to do those transects when the sun was going down so we can get a decent temperature profile of that. And then we also, as I said, monitored carbon flux. So this is looking at basically carbon release, right? So we got there, this was pre-event. So as the city was being built, not everyone was there yet. Only the theme camps were allowed to come and set up. And then we have the main event here, and the man burned. You can see this super downward spike of everyone just being out and watching the man burning and not emitting carbon within the city. And then Exodus is when we see the most amount of carbon upheaval, because you have like 50,000 people trying to leave at once. The city itself, I think that year was one of the biggest years they had. It was about 70,000 people. So you have 70,000 people driving around in their art cars, on their electric scooters or whatever, and just releasing all of this carbon and just being there. But you can also see this really nice oscillation, right, of when people generally go to bed, when they get up. It's a very, very interesting finding. So that was what we did at Burning Man. There was a bit more that came out of that as well. But again, I can link the article from the Urban Climate newsletter or something like that. I have it linked somewhere. So that's pretty much what we did. But then in grad school, I didn't get to go to Burning Man again, unfortunately. But in grad school, I wanted to focus on tropical meteorology. So basically anything that happens in the tropics. It's not just hurricanes. There's more that happens in the tropics than just that. And you may have heard of this term before called an atmospheric river. So we live in California, right? Here we are, right over yonder. Atmospheric rivers, I wanted to look at the various oscillations in the atmosphere that can impact atmospheric rivers, because atmospheric rivers deliver almost all of our water that we get here. Any massive flooding event that California has ever had has been from an atmospheric river. And as you can see, this is a water vapor image. So you can see that there's this little almost streak looking thing that's kind of at Hawaii and goes all the way over the Pacific and interacts with California. So I initially was doing some research about the Pacific North American Oscillation, which is a modulation of the jet stream. But because my advisor, he was a new advisor, and or a new teacher there, and when you're new, they give you money, which is great. But he ran out of money. And so, this initial project did not get funded, unfortunately. So we had to ditch it, which is really a gigantic pain in the booty because I did all of my lit review. I was starting to do my, to do everything. Like I had already read like 20 or 30 scientific articles, which takes so long to do, and started doing all this work, and then we had to ditch it. So very frustrating. Another frustrating part about just school or funding or grad school in general. But thankfully, it wasn't the end of the road. There was an email blast that was sent out to my department from a gentleman from the Lunar Planetary Lab. He was like, yo, I'm working on this thing, and I need some atmospheric dynamicists to assist this project, because I know what's happening with the sun, but I have no idea what's happening with all the other stuff, so I need help. And it was a fully funded project, so my advisor was like, we got to do it. It's what we got to do. I'm sorry. So after me being upset about about a day, we decided to go ahead and join the project. So what he wanted to do was look at the Madden-Julian oscillation and the Quasi-Biennial oscillation and the impacts that these two oscillations together, how they impact the United States or North America. And it was completely funded by the National Science Foundation. So again, sometimes you got to follow the money. And that's precisely what we did. So you're probably like, what in the actual is the Madden-Julian? What are all of these words? What is an oscillation? First of all, an oscillation is a wave. But I'm going to step you through what these oscillations are, and then how they kind of interact with each other, and then how that can influence weather here in North America. So it's going to be a lot of technical jargon. I tried to kind of whittle it down to not be ultra technical. So if I kind of lose you, I'm sorry, but I'll try to explain it as best I can. Okay, so the Madden-Julian oscillation, or the MJO. Essentially, it's this large planetary scale, 30 to 90 day oscillation in zonal wind, so east to west wind, or west to east. Precipitation and surface pressure and humidity, and it slowly propagates towards the east. So it's actually, this is a pretty good representation of what it is. So the shading here shows increased cloudiness, and then the hatching is reduced cloudiness. So more clouds, less clouds. So we can see that it starts over here in the Indian-ish Ocean. I know it's kind of hard to orient ourselves, but this little tip right here, that's India. Okay, so then here's Southeast Asia, and then here's a little tip of South America. So we see quite clearly how this shaded blob just kind of migrates across the, or over the equator. Yeah, so it's the dominant mode of interseasonal variability of rainfall in the tropics. So it's a kind of a big deal. It's very well written about now at this point, which is good. Another way to kind of view it, so you can have this low level westerly flow with your enhanced convection. So this is looking at precipitable water. So if you were to take all the water from the top of the atmosphere to the bottom and squish it on down to measurable liquid, this is what you would kind of get. So the warmer the color in this instance, closer to the equator, is indicating more moisture in the air. So we can see this kind of huge line of enhanced moisture, and this line, or this kind of blob over here of less moisture. So those two arrows kind of coming together, right? So we have this kind of suppressed region here. And what can happen, and in this particular image, we have the MJO, as it's kind of gone over Papua New Guinea here, it has spun out on either side 2 tropical cyclones. One that's coming up and probably enhancing it to hit Japan, another one enhancing about to hit Australia. So some things like this can indeed happen, which is actually quite fascinating and is part of what dream research that I would love to do. Here's just another way to kind of, or how can this oscillation impact what's happening on the US? Essentially, when you have this deep thunderstorm, it's going super high up into the atmosphere, right? And that in turn modulates the jet stream. So you can kind of see that this little bullseye here is what I would call the MJO, or a region of enhanced thunderstorm activity. And it creates this huge wave train over the entire Pacific. So, and we call it a Rossby wave train. Rossby was a dude that founded it, was like, I'm naming it after myself. I was like, oh, lucky you. Anyways, so here's just another way to kind of put it. So this high, low, high is just looking at height anomalies in the atmosphere, basically. And these various height anomalies can translate down to the surface. So even though this is happening like 36,000 feet in the air, it can have impacts down here at the surface, which is kind of fascinating. All right, so that's the MJO. And the QBO, you're like, quasi-biennial, what in the who? Basically, it's this oscillation of winds around the equator that vary between easterlies and westerlies. So from the east or from the west in the tropical stratosphere. So it has a mean period of about 29 months. So this figure here is looking at winds in the zonal winds. So the positive numbers, or the warmer colors, are positive, meaning westerly, and then the cooler colors meaning easterly, if I'm remembering all of that correctly. So you can kind of see this downward motion propagating through the really high up in the atmosphere. This is like super, super, super high up there. And this is modulated by the sun, oddly enough, which is kind of an interesting thing. So what we did is there's two phases. There's QBO East and QBO West. And with that, we can see various impacts along the lines. And we're not the only people to think about this thing. There is other research done by other folks. So what we're looking at here is, I'll kind of explain this top panel. So the blue is the QBO East, and the red is QBO West. So we can see that there's a pretty, and we're looking at the various MJO phases. So and looking at all. So there's a pretty stark difference between the two. So QBO East, the MJO tends to be much stronger, which means the convection, or the thunderstorms, can go even further into the atmosphere. Whereas during QBO West, it's kind of suppressed a little bit. The thunderstorms are like, I'll stay down here. I'll hang out down here. But QBO East, it's like, no, we're going up. We're going to the stratosphere. This is looking at some other variables as well, static stability, so how stable you are, essentially. And what these two figures are showing, basically, is, again, the red being west and the blue being east. There's lower amplitudes, or yeah, less strong MJOs with west, and more strong with east. So we were just kind of able to pass that around. Okay, so now I'm going to kind of start killing you with panels. And again, I'm going to apologize now, but I'm going to break it down. I'm going to break this first one down for you. So we're looking at MJO phase 3. So the various phases indicate where the storms are in terms of the equator. And there's a cute little bubble here to kind of help show you that. So here we're looking at height anomalies. So creating a nice Rossby wave train that I talked about a bit earlier. And then I also am showing the jet stream here in these black contours. And then this lovely little pink arrow is kind of indicating relative wind direction. And on the bottom here, we're looking at temperature anomaly. So anomaly being away from the climate average. So the cooler colors indicating cooler temperatures, the redder colors indicating warmer temperatures. So you can see there's a pretty decent cold anomaly in the Southwest US, and I mean other places around the world as well. And I'm just going to kind of toggle through. So this is phase 3. Phase 5, holy bananas, look at that. That's a huge heating anomaly through a lot of the United States and North America. And a lot of cold anomalies too up in Greenland. And then phase 8, where it's kind of floated around a bit. So going back and forth between the three, you can see how the flow also scoots over closer to the United States, but then also results in some of these huge temperature anomalies. So that was a really fascinating thing for us to put out there. So yes, again, just kind of going back to that idea that the QBO has a pretty decent influence of the MJO. This is just kind of showing that in another way. And I'm once again going to kill you panels, and I apologize, but we can kind of do like a kind of back and forth. I do realize I'm scooting out of time. So repeating a similar analysis. So this is just looking at sea level pressure. So how much atmosphere is on top of your noggin, and the blue indicating a low anomaly and the red indicating a high anomaly, and looking at QBO East versus QBO West. If you're just looking in the various phases of the MJO, 1 through 8, if you're just kind of eyeballing it, right, you can kind of see that the colors on the left are deeper than the colors on the right, right? That's kind of something you can see. And you can also see how it varies with each phase. And these little arrows here are in there to kind of indicate relative flow, essentially. We did also look at precipitation anomalies, but I don't think I included it. Oh yes, I did include it in this one. So again, going back and forth between QBO East and QBO West, as I'm toggling, you can kind of see in QBO East, there's just so much more deeper colors. So this is looking at, this is surface pressure, the left column. Middle column is surface temperature, and right column is precipitation. So we can it's kind of all phased in there. And yeah, so just kind of going back and forth between that. So essentially, I just kind of want to wrap up a little quick here so I can get to those questions. So that's kind of cool. So essentially what we came to the conclusion of is that the MJO and the QBO are very well-known atmospheric oscillations that can have a pretty large influence of these large planetary scale circulations that can impact surface conditions right here in our neck of the woods, right? So something in the tropics can have impacts here. It's more pronounced during QBO East than QBO West. The NAO stands for North Atlantic Oscillation, which is another oscillation of sea surface temperatures. That's a whole nother situation. That have impacts on North America, Eurasia, and various precipitation anomalies in Western Europe as well. And there's just a markedly different pattern between the two phases, which is pretty interesting. And then we also went on to look at how solar variability plays into this as well. So, but the annoying thing about this, I'm just going to go back for a sec, and I know it might be hard for you to see, but if you look at the number of days for each phase here, it's pretty small. It's 166 to 194-ish. So really, really small data set. So it's really hard to get that statistical significance that's needed for good peer-reviewed, for something to be accepted by your scientific peers. So we had to address that in our paper, which took 1.5 to 2 years to get published, which was so annoying. Anyways, so just briefly, I want to kind of just highlight here, this is another way that we can indicate the MJO. So this is going through the various phases. Here's the start, and it kind of swings all the way around here. So I just want to kind of show, this is a dream case study that I would love to do. So the MJO gets very, very excited. So it's more, lots of convection, right? So there was a tropical storm Lorna that formed in the South Indian Ocean. Tropical storm Fanny also formed in the Indian Ocean, but the North Indian Ocean, right? So again, kind of doing those two little cyclones on either side of the hemispheres. Tropical storm Fanny made landfall in India as a Category 4 hurricane, did a lot of damage. But then, like a week later, about a week later, 2 weeks later, excuse me, there was an atmospheric river event in California that was induced again by this MJO structure. And there was a huge, like 17-day severe weather outbreak in the plains, in the like tornadoes every single day. which was pretty crazy. So overall, just to conclude, I mean, all my research and stuff like that, but you know what? Follow your dreams and your opportunities. Take whatever opportunity comes your way. Do you have to have 5 internships? Maybe not, but is it going to give you experience? Maybe. You never know where life's going to take you. Even if you don't get your dream job, school, internship, whatever, never give up, right? Take whatever comes your way with stride. Don't get too bummed out if something doesn't go your way. And life is really hard. School's really hard, but you have people around you to help support you and love you throughout your journey, whether it be friends, family, peers, teachers, counselors, etc. We are all here to help you. Every day is a new day. The pain and suffering you're going through today is probably not going to transfer to the next day. And of course, my end bullet point here, travel. Get out of this country. Go see other places. Go meet other people. The rest of the world is really cool. I highly recommend it when we can, of course. And that's it. Whew, kind of breezed through that one. So feel free to contact me. There's my email. Any questions, comments, or concerns are very much appreciated. Yeah, thank you all so much. Oh, thank you. Thank you. So yeah, if you're a student of mine, make sure that you do that sign up thing, right? The Google form, so that I know you were here. And yeah, if you have any questions, holla at your girl.
Thank you so much for sharing your educational journey, your various journeys, and your research. So there are a couple of questions that came up in the chat I want to kind of pose while we have the recording going.
Yep.
One in particular that popped out, pertaining to your research, what happens when the temperature anomalies shift up towards the poles?
Yeah, so I think that was when I was going through that. So it's basically like a from what I can remember, it's pretty much a shift in the circulation. So when you're blowing all of this cold Arctic air into these regions, then you're making it colder. Yeah, so that's kind of the dealio with that, essentially. I saw another question. What data are storm chasers collecting and what precautions do they take to not be harmed in the process? So that's a fun one. So storm chasers take so much data. If I went to Huntsville, when I went to go visit them, they have this ambulance that they converted into a storm chasing vehicle. And so they have all these kinds of instruments on their cars or on that vehicle, taking temperature, relative humidity, there's a radar, a LiDAR, like all these different things that are on there to hopefully keep them safe. And they have tons of computer screens in there too. So they're getting data from the National Weather Service, Storm Prediction Center, Weather Prediction Center, etc. And they just got to make sure that they're not in harm's way of a tornado. So if they're being safe and if they're not in really bad traffic, sometimes there's a lot of storm chasers out there and you can't move. So hopefully you're kind of on the southeastern side of a tornado rather than the northwest or northeastern side of a tornado. Otherwise, you might be in the way. Were there any other questions that kind of popped up?
If you can, I would definitely save the chat. There's a bunch of thank yous, a lot of shout outs for having an inspirational story. Can't agree more. We did have 1 2-part questions that popped up into the chat. Let's see. So first question, curious what time of day you do most of the research? And second question, please, is there a huge fan vacuum intake, CO2 and exchange O2 project, and is Burning Man back to Baker Beach and SF, paying an homage to the founder last year?
Yeah. Okay, so for the first question, what time of day did I do a lot of my research? So I'm personally more productive when the sun is up. So I would go into my office around, first of all, I had to get there because parking was awful. So I had to get there around like 8:30 or 9. So then I would be on campus from 9 to about 4:30, and then I would go practice yoga and decompress, because staring at screens all day is really not the business, as we all know now, I think. So for me, that's when I'm most productive. And then what was the second question?
Regarding Burning Man,
Yeah.
converting intake vacuum for CO2 converting to O2, and Burning Man back to Baker Beach.
So I don't have an answer for that first part of the question. So sorry about that. I don't have that one. But oh, okay. Now
Oh,
I see.
yeah, there's a clarification in the chat there.
Okay. Whoop, 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 whoop. Burning Man, what time do you do research? Ha! So while we're there, when we're there, we're just taking data. We're not doing any research while we're there. We're researching other things, not what we were taking data on. So basically, we got all of this data into these huge data files, and basically like thumb drives, if you will, for lack of a better term. And then when we got home, cleaned all the dust off everything, and then went through and did the analysis. So that's kind of how field work goes. You go, you take all this data, you collect all of it, and then when you get back to a quote unquote safer location, or just back to your home base, your home computer, that's when you do all that research. Yes, you're very welcome. Thank you for your questions.
All right. Let's see. Being respectful of your time, I'm going to close out the recording here. Thank you all for being on the call. And if you guys are watching this on YouTube, feel free to join us every week. The link for joining the meeting will be in the description below. But every Tuesday, 4:30 to 5:30, we host Science in Action. And if you have any requests, feel free to let us know, and we'll try to do our best to accommodate. Thank you again, Professor Redman. I can't thank you enough for sharing your journey with us and your research.
Yeah, thank you so much for having me. I appreciate it.